Should be on now.
Okay, can you see him?
Yes.
Okay, can you all
It's
see
on
him?
now.
Okay. Okay, good evening,
Yes, you can see
everybody.
it.
Yeah, good evening, everybody, and welcome to today's tutorial. Last week we learned about bringing in vector data into GIS, how to manipulate, do some symbolism. So today we are going to talk about coordinate system. The first lectures or talk we had, I talked about the problem we usually face in GIS is that you have data from different coordinate systems, from different projection, and you have to know some basic things about coordinate projection, how to change it, and the rest. So some software have a shortcut, like if you are using QGIS, you can work on it. When you want to like export the data, it will give you an option whether to project it or not. When we talk of projecting a coordinate, is just representing three-dimensional surface on a two-dimension, because our maps are produced on two-dimension paper, while the earth itself is not a flat surface. It's a curved surface, but we just have to think of a way to represent the world in two-dimensional. Is there anybody that didn't do survey here? Maybe that is not from survey background. Is there anybody in the house? Is there anybody like that? Yeah, you can. Okay, you can unmute yourself if you want to talk. Do we have anybody like that? Okay, I guess we do not have. So somehow we are familiar with. Hello, do we have anybody in the house?
Yes, yes.
Okay, what's your background, please?
Geology.
Sir?
Geology.
Yeah, but even as a geologist, you know about GPS coordinate, right?
Yes, I do.
Okay, so what we just want to talk about is about coordinate system. How, you know, we have longitude and latitude. Then we have a metric system, which is projected that you can measure distance, because with a longitude is a curved surface. So that's just what we want to introduce you to, because you will come across different type of data, but you should be able to know how to project one. And there are some analysis that you cannot do if your coordinate is not projected. Like if you want to do hotspot analysis where distance is to be measured, you need the system to be able to know if it is in kilometer, meters instead of degrees. So Bolarewa, I think you can proceed now. So okay. I will unmute myself. I will mute myself too. Where am I?
Okay. Good evening. You're welcome to today's class. The topic is coordinate system, projection, and so the training agenda. The first one is we look at the geographic and projected coordinate system. We want to look at the difference between the two. Then from there, we look at how to identify a dataset coordinate system to know which coordinate system are we working with. Then the third part of the session is changing a dataset coordinate system from one coordinate system to another. Then we'll also be looking at creating a custom coordinate system, but that will not be today. It will be the second part of this training, and how to correct for error in projection. Then the last one will be how to georeference any maps that we have. Now let's look at the geographic and the projected coordinate system. So what is geographic coordinate system? A geographic coordinate system is a coordinate system that uses three-dimensional spherical surface to define location on the Earth surface. A GCF also referred to as geographic coordinate system, is often incorrectly called datum. Many people call it datum, but it's more than datum. A datum is only one part of GCF. So GCF include the angular unit of measurement, the prime meridian, and a datum based on a spheroid. So there must be a spheroid defined based on these three parameters. So we will soon look at it in ArcGIS to see how we can identify the projected coordinate and the geographic coordinate system. So a points on the geographic coordinate system are referenced with longitude and latitude value. So longitude and latitude value are angles that are measured on the Earth surface from the center to a point on the Earth surface, and the angles are often in degree or grade. So the following illustration shows the world as a globe with longitude and latitude value. So when we look at this, you can define any point on the Earth surface with their latitude and their longitude, and the unit is always in degree. So I want us to take a look at the projected coordinate system. What is it? Actually, from the geographic coordinate system, we are coming from a word that is assumed to be sphere. Now, we cannot be working on a sphere because of the complicated mathematical calculations that it is involved, especially, let's say you want to find distance between 2 points on a sphere. We have a long, very long formula to do that. So it's easier to work on a plane surface. So most times, what scientists do is that they project from the sphere to the plane surface. And that's why we have a projected coordinate system. So projected coordinate system is coming right from the three-dimensional Earth surface to a plane surface. So a projected coordinate system is defined as a flat two-dimensional surface, like a geographic coordinate system.
Can you let people in? You know you are the host, please. Can you let them in?
Okay.
Yeah, just check. Do you have anybody that is?
Yes, we have like 3.
Okay, please accept them. Just be checking.
Yeah. Okay.
I thought I could do it from here. Okay.
Yes. Okay, like I was saying, we have projected coordinate system is coming directly from the geographic coordinate system. We have to project from geographic coordinate system to a projected coordinate system. So a projected coordinate system is always based on geographic coordinate system that is based on sphere or spheroid. So when you are defining any coordinate system, you should be able to tell us from which spheroid is it coming from. In Nigeria, we have 2 that we normally use. We have WGS 84, which is almost a universal spheroid, and we have Datum. So we will look at this in ArcMap to see. Sorry, let me admit some people. Okay, to see how we can actually use this in a real life scenario. So let me open my ArcMap. I hope all of us are with our system. We can just launch our ArcMap now so that okay. Let me launch my ArcMap now. Can you see my screen? Hello? Okay.
No, we cannot see your screen, please.
Not yet. Not yet.
Okay, it will appear now.
Yeah, we can't. I can't see your screen also in this place.
Okay.
Connection is unstable. Why you leave? Listen, continue.
I think you should be able to see it now.
I can't say it here.
No, it's not coming up. It's not
It's
coming
still
up.
not coming up. What is showing is just a long horizontal line, white horizontal line.
Okay. Even now?
Yes. So you need to select which of the screen you want to share.
Yes, I've selected my screen. I don't know. I'm coming. Let me stop it and start the screen again.
Can you check if some people are still waiting for you to like add them?
Okay.
Okay.
Okay. Only one person. Okay.
Yeah.
It's up now.
Yeah, it is.
Okay. So this is my ArcGIS. ArcMap open.
Sorry, have we all have ArcGIS open so that we can walk through it together? You know, I sent you a
I've
data.
opened it.
Yeah, please open your ArcGIS so that we will go through
Mine
it.
is still loading.
You have a slow system, right?
Not really slow. It's just that it is just full with
Okay,
with
let's just give them some time. Yeah,
apps.
you may
Yes.
have to like remove some things to
Yes.
remove some software. So let's give time because they either let us click it, not just to watch it, although I will put it on the YouTube. Still check if there's someone still pending to add them.
Okay.
Yeah, just be checking time to time. Thank you.
Okay. Can we continue now?
Yeah, I think we can. Yeah.
Okay, we can continue. We can continue.
Okay. So this is my ArcMap, and anytime you open ArcMap, this is the first place it will show. Most times it will show you your recent work. This is my recent work, but I don't want to work on this. I want to go to a new map. Can you see my cursor? So I want to click on new map now. It give me a black map, so I need a blank map for now. So anytime you open ArcMap, it give you your layer like this, an empty layer, no data sets yet. So if you right click on this, you can go to, you will see part of the context menu that was showed. We have properties. So in these properties, if you click on properties, it will open these data frame properties. From there, you will see the two major coordinate systems highlighted: the geographic coordinate system and the projected coordinate system. So we are going to look at these two together now. Let me check. Some people are already. Okay. Now, let's look at the projected coordinate system. Under the projected coordinate system, you can see Africa, Antarctica, Asia, Atlantic Ocean. So these are various geographic coordinate systems that we have. But as concerns us here, we'll be using Africa. And under Africa, our target is MENA. MENA is down. Yes, this is MENA. So I'm just showing this so that we know how to get our geographic coordinate system and the projected coordinate system. So I want to go back now to another thing under this geographic coordinate system. What if we want to use WGS? You come down to World. This is World. Under World, we have some international geoid. We have some international geoid, and then we see WGS. We also use WGS in Nigeria. Most of our GPS observations are based on this WGS 84. So let me go back to projected coordinate system. So under projected coordinate system also, the two common the two common projected coordinate system we normally use is either we use the UTM, WGS again, and we go to the north hemisphere because we are in the northern hemisphere. So we use either zone 31, zone 32, or zone 33 in Nigeria. So these are the zones. You select it here. Come in.
Sorry, please. Before we go far, I want
Okay.
to ask a question, please, because
Okay.
it took you a bit of time before you grant me access. So I did
Oh,
not
sorry.
really meet the class from the beginning. Can you just brief me on the difference between this geographical coordinate system and the projected coordinate system?
Okay. Geographic coordinate system is a three-dimensional coordinate system and is measured in degree. It's measured on a geoid. On a spheroid. Let me, I don't know. I don't want to go to the, it's measured
I think,
on,
wait, Ganu, is it Ganu that is asking the question? Hello?
hello?
Yeah.
Yes, sir. Yes, sir.
Yeah.
Yes.
The major difference is that the geographic coordinate is measured in degrees, minute, and second, longitude and latitude, while a projected coordinate is in metric in either meter, kilometers, that you can measure distance. That is just the major difference. One is angular along either the longitude, latitude, which is on a curved surface, while one is on a flat or two-dimensional surface. Is that okay?
I'm okay with that. Thank you.
Yeah, in case it log us out in the next few minutes, we will use the second link I sent to you. It's just 30 minutes now that we can work. So it's okay.
Yes, sir.
Okay. So what I want us to note in these two coordinate systems is which one do we use in Nigeria? We use the WGS for the projected coordinate system, and most times you find it under the UTM. Then you go down, you will see world. See WGS 84. So under the WGS 84, we have the northern hemisphere and the southern hemisphere. We are in the northern hemisphere, so we have to take northern hemisphere. Then we look at WGS zones. We have different zones that we can use. Like in Lagos here, we use zone 31. In some part of Nigeria, they use zone 32. I think in some part of Nigeria also, they use zone 33. So you have to know which zone are you working with. So the same thing apply to under projected coordinate system. So as we proceed in our practical, we get used to these two coordinate system because I will have some sample data that has this coordinate system, which we can look at very soon now. So let me proceed with my coming. Okay. Hello?
Yes, we are with you.
Okay.
Your screen is awesome.
Okay.
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 But yeah, back to the PowerPoint.
Yes. So now I want to see how to identify a data set coordinate system. Assuming you have any data set, we have two categories of data sets. we have the vector data set, and we have the raster data set. I hope we've not forget that. So we will be working with the two types. So how can we identify which coordinate system these data sets are? That is what we want to do now. And the steps are very simple. First, you have to launch your ArcMap. Then you add your data set. This could be a shapefile, feature class, or imagery in any raster format by clicking on the Add button that is shown below. I hope we can see it. So you click on this plus button to add your data set to ArcMap. So the thought is to navigate to the file directory where your data set was saved. And this is shown by this illustration. Once you click on Add button, you will have to navigate to where your data set is saved on your system. So you have to click on it and click Next and click Add button, which is below. Sorry, this thing cover my. Click Add button, then it will be added to your ArcMap. Then right click on the data set layer on the table of contents panel. I will show you where the table of content panel is, in case for those who do not know where it is, and select the property value as shown below. So this is table of contents here. Then you just click on the data set you just inputted and right click on it. Go to property. Once you click on property, it will give you these layer properties dialog box. Inside these, you will see general, source, selection, display, symbology, feed. All these things are useful, but what we want to use now is the source. We want to know the source of our data set. So when you look at that source, you look down, you will see data source. From the data source, you will see the coordinate system that you are working on. In this example, I'm working on GCS WGS 1984. That is, I'm working on a geographic coordinate system. So the unit that my ArcMap will be displaying for me is in degree, is in latitude and longitude, which is measured in degree. So we will also look at how to change a data set coordinate system using ArcMap. But before then, let me share my ArcMap, or let me quickly go through this manual, then we do the practical together.
We will soon be logged out. So in case you will, maybe what we'll do, why not we go to practical, since all of us have the manual. We'll just go into the practical.
Okay.
Yeah, since we all have the self-explanatory.
Let me.
So in case we are logged out, you just log in again. I will start another.
So just joining this thing now. I'm not with the manual.
No, but I sent it now.
And you will get it. I
will still put it.
I will make sure I explain everything.
The idea of the manual is that so that we will just go through it instead of this training is more of practical. So we don't want to do much reading, since the manual is there. When he click, you will take a look, and when you are lost, when you get back home or after the meeting, you can also watch the video and then follow the steps. We have just 30 minutes, so, and I don't want it to exceed 1 hour because of those fasts, and some people need to rest. Is that okay?
Yeah. Yes, I understood, sir. Thank you, sir.
Yeah.
That is perfect. Let him not repeat the manual.
Yeah. Still check if there are people who want to join.
Okay. I've admitted some people already.
Thank you.
So I think everybody can see my screen now.
Yeah, we can see.
Can you see my app?
Yes.
Yeah, everything is seen.
Okay. I want to close this ArcMap. I want to show us something because I will be doing some geoprocessing I will be using the geoprocessing tools. So it's better I create a geodatabase file
But
for
I
me
hope
to
it won't take
avoid
time.
any error.
I hope it won't take
It
time.
won't.
Okay.
It won't take time. It won't take
Okay.
time. So let me just close. I will open it back now. Just to follow the right procedure of opening or creating a new project. So we all have the training material, and inside the training material, we have 3 files, like 4 files there. We have the road shapefile. There's a road shapefile there. That's road network of Obanlinde area in Lagos. Then we have the another point of interest. These are point files. Then we have one raster data of Banana Island in Lagos State. So I will be using these 3 for the work. Now my ArcMap is ready. I go to the new map. Under the new map, I select here already. I've already created my geodatabase, but I want to create a new one for the purpose of this training. So I click on the envelope. You see the yellow envelope down here. So you have to select your directory where your data is. So I'm already in my directory now, training material. So you also have to select where your data is. Then at the top left here, you will see new file geodatabase. You have to create a new file geodatabase there. So if you like, you can change the name, but me, I will leave it as default like this. So then I will make it my default geodatabase. You will see the icon for default geodatabase on the top here, where my cursor is presently. So just click on it. It will make this database, sorry, coming. Training material. So, okay, another way of doing it, just right click on this new file, new geodatabase that is created. Sorry. Or just select it that this is the one you want to use. Then later we can go and make it default. So I've already created my ArcMap, not named yet. So let me input one of the data file or data sets. Let me start with the road network here. So this is road network of Obalende. That Obalende area is an SCDA. So you can see Banana Island that we have the imagery also. So how would I know the coordinate system of this road system? I check this property again. Then I see that it's in GCS WGS 1984. Now, I didn't want to work in WGS 1984. So I want to project it to WGS Zone 31. You click on the R2 box up here. The icon is red. So under the R2 box, you just go to Data Management Tool, the one I highlighted here. Click on the plus button. It will show you all the functionality in that app box. Then you can go to projection and transformation. Click on the add button. Then click project, because now I'm working on a vector data set. So I will have to click on project immediately. But if I'm working on a raster data set, under the projection and transformation tool, there is a raster functionality also. So if I click on the plus there, I will see all the functionality I can do with this, with raster. But now I'm not doing raster, I'm doing vector. So I will click on projection straight away. So clicking on projection, you select the data set you want to project, which is Ikoyi Obalende Road. You wait for it to resolve, because as you click on it, it's trying to detect the coordinate system it is. So it may take some minutes.
Sorry, I'm very sorry
So
for taking
now it has.
Hello.
It's like
Hello?
someone wants to say something.
Hello?
Yes, sir. Yeah, but my own belief is that it is only raster image that we coordinate. Is it possible to recoordinate vector data? And
What?
that's my question.
Recoordinate what?
My question is it possible to recoordinate vector data? Because what I understand is that
That is what we are just doing now. No. That is what we are doing now. We have to vector and raster. We are doing vector first, but you don't use the same function. So is the vector, if you look at the rod, you can see there are a shape file. You can see even from the layer property is line. While if it is vector, you can't see shape file, you see color, values. So this is vector.
Okay,
Is
sir.
that understood?
Yeah.
Yeah. Okay, proceed, please.
I think based on the question, if you want to recoordinate it, we still get there. We still get there. Maybe you don't know. They are just a paper file, like an image. There's a way of doing that also. But we'll get there now. For now, we want to do how can we project to another coordinate system? That's what we are talking about now. So the next step for me now is to tell the system my output coordinate system. And the output coordinate system that I need is WGS 1984 zone 31. So I will click on this icon here. So it will bring out this dialog box from which I will select projected coordinate system. Now, note, we are going from geographic to projected coordinate system now. Before that, let me show you something. If you look at your ArcMap, I'm coming, let me admit this person. If you look at your ArcMap, sorry, I have some people that are just joining. Okay. If you look down your ArcMap, you will see that the unit of your data set presently now is in decimal degree, showing you latitude and longitude. But now, by the time we project this data, we'll be having a metric unit, telling us that we are now on two-dimensional surface. So let's click on projected coordinate system. Under the projected coordinate system, just go down to UTM. Sorry. To UTM, then down to WGS84. Under the WGS84, click on the northern hemisphere. So now scroll down until you see WGS 1984 UTM zone 31. So I'm on WGS 1984 UTM zone 31 now. So I click OK to accept it. So it will load that coordinate system into my application. We wait for it. It will appear here after some time. So I have to wait a bit. Yeah, it's done now. So I don't have any other thing to do again. Every other thing is optional. So I just click OK. Then you will start the process immediately. Down your ArcMap, you can see the process. It tell you it's transforming. Actually, the result of this projection is that it will create another feature layer in that coordinate system. So once it's done, you can remove this initial coordinate, initial data set that you inputted into your ArcMap. Then you start working with the projected one. Now, since we are going from WGS to projected WGS, there is no error. But at times when you are projecting from WGS geographic coordinate system to MENA, there are bound to be some error. You will see some shift in your data. That is one of the problems we are going to tackle in our second class next week, by God's grace. So the file is ready already. It's already projected. You will see it in your table of contents, and it will append projects. So you have a projected file now. So now you have successfully projected your data set, which is vector data set, into WGS 1984 SOM 31. So now we can do the same process for raster data. Let me bring in a raster data. If you like, you can start from the beginning,
sir.
but
Sorry, before we go far.
okay.
The question. After we've converted here, I discovered that what you make mention the other time, the decimal and degree, is still in decimal and degree. As it is
Yes.
before we
Because ArcMap, hello?
Yes,
ArcMap work with the first data set you inputted into it. So now, assuming I didn't want it to be in this decimal, I have to close my ArcMap and load this one that I've just projected in, and it will be the base.
Voila.
That metric, yes, sir?
Go to layer, right click the layer up. Layer itself.
And
Yes.
change a unit. Okay.
Yes,
Okay.
so you can like do it from there if you wanted. You know, you can set your layer from the onset to WGS or whatsoever. But as I said the first lecture, that ArcMap can recognize anyone from different projection. But another way is to go to the layer, set it in meters. So if you can set it, then go to data frame. Let me see. Yeah, they go to click.
It's already in meter.
Off. Okay, so hopefully it should work now. Go to coordinate system too. You can set the coordinate system. The layer
I think it's already in meter. I'll change it to meter.
Okay,
Yeah.
now go to coordinate system up.
I'm coming.
Okay, yeah. So it is now in meter. So that is one of the way you can do it. You can go to the layer itself. And there are times that if you have projected, if your layer is projected and you want to export this same data, there is a way that ArcGIS will ask you whether it should export with the layer coordinate instead of the file coordinate. So when you get to use the ArcGIS, you will know some shorter ways to like get things done without going through all this long process. But that is left to you to go and sort it out. So we are not teaching everything here to make it fun. I hope you're clear now.
Yeah.
Okay,
Hello.
proceed, please.
Hello.
Yeah.
Hello.
Yeah.
Hello? Yeah, Victor.
But just like he said, after projecting, if you just delete the initial file, the imported data set, and then pick up the projected data set. That will automatically.
Hello, we lost him.
Hello.
Hello, Vic.
Me?
Hello. Hello, Victor.
Hello.
Yeah.
Did you get what I'm saying? I said.
Yeah. I get that. I'm just trying to like show you different options. You know, I said something that you can use more than 1, 2, 3 to solve
Method,
one
okay.
problem. Yes, just for you to know
Yes.
various ways that if your layer, you can set the projection from the onset.
Perfect.
So every other coming, it will go in. So if you want to export it, you can tell the system export it based on the layer coordinate system, and it will just project it for you. Is that okay?
Thank
so
you.
I just want to like know different ways to do things.
Okay, can we continue with the raster now?
Yeah.
Yes.
Okay, so let's try to practicalize the same procedure with raster data. So I'm selecting Banana Island imagery here. So this is Banana Island imagery. You can see. So we want to project it also. We want to have a projected copy. So this imagery.
Hello, sorry, sir.
Yes, sir.
Can you try to export this Banana Island so that I'll just show them what I was saying about another shortcut? Just try to like right click it, go to export.
Okay.
Yeah, go to data, export. Okay. If you see up, you can see the extent, you can see spatial reference, you can use data frame, which is up, instead of using raster data set. So if you use data frame, it is going to take the coordinate of the data frame, which is just click the data frame. Let's see the spatial reference. Just check the data frame. Yeah, check the data frame.
Yeah.
So if you want, you can. Which one is okay? Go to extend current frame. So there is a way, if it is vector, it will take the data frame. If the data frame is projected, that is what it will use to export it. Is that understood? So instead of using original, but I don't know why this one hasn't changed. Ordinarily, the cell is supposed to change to XY coordinate now. So you can close it. I just wanted them to know how we.
Okay.
I don't know why this one is not doing. And also there, if it is QGIS, you can even set the coordinate system from here. It will give you an option, so you can export it to different projected or geographic coordinate system. Okay, proceed. I think our time, so you have to be a bit fast now.
Okay. So the process for projecting the raster data is still going back to our Arc toolbox. And instead of selecting this project, I will go to raster because I want to deal with the raster now. Then I go to project raster, which is the one I highlighted here. Double click on it. It will bring out a dialog box. You have to wait. Yeah, it's ready. So we have to input our raster data, which is already open in our application. So I will select Banana Island. It takes some time. We have to detect the coordinate system it is. Okay, now it's ready. Then I will have to tell my application that it should project to a specific coordinate system, which will be my output coordinate system. So I have to select my output coordinate system. Still the same, I'm going to WGS. So
can
UTM.
You check, sorry, can you check? It's like someone needs to be logged in. Can you check?
Okay.
Sorry.
No, nobody. Okay. Yeah. Oh, so under the UTM, I want to go down to, to WGS, then Northern Hemisphere, Zone 31. Zone 31. So I'm done. So I can click OK. It may take some time because this raster, he has to do the, actually you can also set the resampling technique, but I will suggest that you leave it as nearest. But you can, there are other options that you can set, bilinear, cubic, majority, but leave it as nearest for now. That's the interpolation techniques that you will use to resample the image after projection. So I click OK. So you will see that it's already doing the processing here. So we have to wait.
Yeah, when you finish, right, go to the layer, set it to the same coordinate projection with this one, so that we will export that equally and see if it will work. Yeah, set it to the same, property. No, property. Go to property.
Okay.
Check the coordinate. Yeah, you see it's on the BlueJS 84, not on projected. So that's why it wasn't giving us that option. So choose projection also, projected.
Yes.
Then put it in the same. Then we will try that equally Oberland. Is it Oberlandero? And see.
Okay.
Yeah. I think is it touch one?
Yes.
Yes. Okay.
Live.
Okay. So when you're done with this one, try to export that one that hasn't been projected. Let's see if it will give us, when we pick the data frame option, if it will show us the coordinate.
Hello, sir.
Yes.
Hello, sir.
Yes. Yes, ma'am.
Good evening. I got stuck in projection of this raster.
Of raster?
My network was bad. Please, can you retake it, please?
Sanusi, we will put the video because of time. And also, it takes time before it runs.
Trying to move it, this special reference properties. Okay.
Don't worry. Let us finish. If we have time, he will repeat it again. Okay, now it has. Okay,
you can always watch the video back and back, so that. But the projection is done now. As you can see, give me a report here that my projection, my raster projection is okay. Then it had that layer to my table of contents. As you can see, this is Banana Island projected raster. So let's try the export that we are talking about the other time.
Okay.
This current.
Yeah.
Data frame. Okay. I think if you want to export, let me start again. This is my original data set that I input, and it's in WGS 84. That's Geographic Coordinate System. You can export it to the data frame coordinate system, which is WGS 84 Zone 31. That's projected coordinate system, just as Mr. Kuta was saying the other time. So by selecting data frame,
you can see it has changed now. You can see extend left, top, right. It has changed to UTM now.
Then he identified it, WGS 1984 Zone 21. So that's another way of doing your projection. You want it very fast. Then another thing I want you to note, you see that the image I input, this data set is in ECW. That is compressed electrophilant wave format. is the best format to be used. If you don't want to raster data to be very, very big, you have to use this format. But most times it's not free to have this format. But if you are using SatPlanet to download, you also have this option of saving your output file in ECW. So I will encourage us to be using that ECW. But if you want to export it, you will not see that option in ArcMap. You can look at it very well. There's no option of exporting in ECW. So you have to export in TIFF or JPEG. So what that means is that you will have have like 2 or 3 different files. Your image, then other coordinate system file that will be attached to it. So we have to take note of that also when we are exporting. So if you want to copy the file to someone, if you don't copy the other file, that file may not be georeferenced where that person is taking it to. So we have to be careful of that also. So that's on raster projection for today. I don't know if there's any question.
Try the vector also. Export it too.
Okay.
Yeah, just for that one.
Data, export data. So you will ask you where you want to save it.
Yeah, you can choose the data frame, click it too, but they may not see it. Sorry, you can choose data frame too. If it is in Geographic, it will just take the coordinate of the data from which is projected. So there are many ways that you can use. Most time, if I want to be lazy, I don't go through that projection. You just set one. So there are different ways that you can maneuver GIS, and that is one thing with GIS, as I told you before, that there are standard rules anyway, but that doesn't mean that one good thing within that you can see more than one function in 2 places. One function that will do something, you can see them embedded in 1 or 2 places. Some of them are in Arc catalog, and some of them are in this main menu. If you go to geoprocessing, you can do something that you can still do from the Arc catalog, like a clipping and some other thing. Especially vector analysis is done using the main menu, even without going into Arc catalog. But raster, basically, you need Arc. Arc tools. Sorry. So Sanusi, our time. Sanusi was saying something. If you can maybe go over it. Sanusi, I think you were saying something, right? Or any question? Should I unmute everybody?
Yeah, don't almost yet. My own question is for me to get this tutorial very well. Is for example now you have your raster data in another coordinate system. But what I've gotten from this tutorial so far, so as to be clear, is you can actually project it to another coordinate system maybe in case you want to georeference again. Is it that what you are trying to explain, sir?
No. You know, there is difference between transformation and projection. Projection basically is from geographic to metric. Then transformation is what you can transform in. Like what he is using is WGS84, not even Minadatum. You can transform this same thing to Minadatum. Do you understand? Because all of them are on metric. So if you don't want to work on WGS, you can take it to Mina.
I think if I hear the person very well also, there's a difference between georeferencing and what we are doing now. We will still go back to georeferencing. Georeferencing is you have a data set that have an arbitrary coordinate system that you don't even know. And you want to put it in your own real coordinate system, since you know the position where those where the data set is being taken. So since you can identify some prominent points in that image, you can do references. That's another topic entirely. But this one is projecting from one coordinate system to another. So another thing I want us to note in this projection is that you will see that I'm projecting from, I'm not projecting from different ellipsoid. What I'm doing is that I'm projecting from WGS, which is Geographic Coordinate System, to projected WGS. That I'm projecting from, I'm still on WGS.
The same surface, yeah.
I'm still on. So that's why you didn't see any error. I want us to know that very well, because it occurs in real life. Even when you are doing your work, most times you just discover that there are many, when you project, your data is not sitting appropriately. I would have liked to practicalize that if time can permit us.
Yeah,
I will project it to me now.
Yeah,
then you will now see the shift.
Yeah, the time now will not. And the simple reason why you will see the shift is that the global ellipsoid is different. You know, each country, you know, the earth is not flat. If you look at the distant poles, the poles are like a squash. Somebody squashed something, they are shorter, but the equator are elongated. So if you're transforming from one coordinate system to another, there will be a shift. It's just like taking an orange. You know, when you try to make orange to be flat, some part will tear. So just as he has said that if you transform from one coordinate like WGS to Mina or to local, you will see different, there is going to be shift. And that's why each country choose a coordinate system that fit, like those along equator. There's one particular coordinate or UTM. All of them are UTM anyway, but there is one that fits them better than the countries at the poles. Do you get, you know, country at the poles, they are more of a curved nature than those along the equator. So, but you know, that is why they say there is a book called How to Lie with Map. No map is 100% accurate, because there are always shifts, and that's why in those that this survey we say we don't know the true value is the most probable value, because there will always be error. The art is curved, but you are representing it on a flat surface. So that is where the problem is. So there will always be shift, but if the shift is allowed or is within the allowable error, then you can do without it. So, is that okay? Any question?
Yeah. I think another solution to that, although we will talk about that in the second session, is creating your own custom projection system. And the data you will be using is just a 7 transformation parameter. But that one is gotten through mapping of a state. Yeah. Hello? Who is that?
Can you hear me?
Yes, I can hear you. Fito.
Thank you for your effort. You see, what matters is not how many lessons or practical we're able to do. What matters is the quality and what we're able to get from it. Just like you are saying, the basics, so long as surveying is concerned, the most important thing is to make sure that we get the most probable value, getting closer to the probable value. And it is all about this error, minimizing error in terms of georeferencing, in terms of projecting, in terms of repositioning. So I would advise, just like Kuta is explaining, we don't mind time. If it need be, we do it over and over. I'm not talking of this one you have done. I mean, taking the other directions, if projecting in Menadatum, which is our basic, so that we can do it, so that we get it. The quality lectures and the practice we do is better than the covering over all the whole things, and at the end, it still boil back the same thing. I don't know whether it makes sense.
Yes, I get you, sir. So, actually, the way this thing is designed, we stop on this level today. The other thing I'm talking about will be handling in the second session.
Yes, thank you.
Projection, correcting for error, we will be doing that in the second session of this practical. So I'm only telling us that the reason why we are not having error now is that we are still on one spheroid. which is WGS.
Except when
Kudos.
Hello, any other question?
So if there is nothing after that, then we'll now go into the, I think when you take this one next week, then we'll go into the where we will do, which will be for the lesson 4, right? Spatial data creation, editing tools by digitizing technique, exporting and importing. We have taught part of it, how to export to different formats, to CAD and some other things, modifying existing layers. So that will be week after next, then after you have done the second session, because this one is quite important. I told you that there was a time I spent with trying to georeference a map that was done in local, not even Mina. So I hope in the absence of no question, I would put this one up on YouTube maybe today or tomorrow, so that those that are not able to catch up or not able to join us can go over it. Please, I will advise you to always go over the practical. The more you keep them thinking you will come back and go over them, it may be hard. And I also encourage us to do map and put them on Facebook. Let us critique so that we will improve our skills, especially cartographic skill. You know, it's quite important. It's like a lady that doesn't make her face look beautiful, even if she is beautiful. So, you know, sometimes when you like produce a map, even the cartographic output alone is not something else. So we need to know that. So is there any question before we call it quit? Then I'll upload in the on the YouTube.
Is it only a lady? Is it only a lady? What of a man that does not brush his head
sorry. Sorry.
Okay, it is not only a lady. It's just like a man, a man that is handsome, but he will not shave his beard. He will not barb. You know, he will not even like brush his teeth. You know, when he goes and say, "I want to marry you," and the lady see the face,
better. No. I think it's better. The example is better than using a lady.
Okay, okay, it's okay. So
thank you, Mr. Emeka, for fighting for us. So.
Okay. So 10 minutes. See her, Sanusi. It's okay.
Sir?
I say, see you. It is okay. It's like Zoom is gracious to us today. Or they gave us
very gracious, sir. And what I experienced from the maps. Sorry, what I experienced from the map is that it's like most of these maps they take some kind of funny shape. This one is looking like a chameleon right now.
This is
sorry. I'm having it. I go through this thing now.
It's just bearing the name banana. It's just a banana.
It's looking like it's looking like a chameleon.
They call the place Banana Island. So
please, I want to ask a question, please.
Yes, sir.
Yeah. Okay,
because
sir.
I'm trying to go through this thing now, but I discovered that my decimal degree is not even changing, even after I do that export. That makes sense.
You mean your coordinate system?
Yes, it's not.
No. It won't change. You know. No, that doesn't mean that it has not projected. The thing is the layer. You have to go to the layer and change. Yeah, because ArcGIS can overlay any type of coordinate system. So, but the layer itself has to be changed before you can see the metric. Maybe Bola, go back there again and just show him. So that is one.
I think if you want to do it. If you want to do it, just come to layer. Can you see layer here on the table of contents?
Yes.
So right click on it, go to property. Can you see it?
Yes.
Okay, click on property. Now, under property, we bring out this box. You will see future cache, annotation group, extend indicator. But our focus is on coordinate system. You will see coordinate system here.
Yes,
so now under coordinate system, go to projected coordinate system.
Yes, I'm there already.
So once you are there, go to UTM, uncheck UTM. You will see it like this, but uncheck it. So now go down, you will see WGS down.
Yes.
So once you see WGS, go to WGS UTM Zone 31.
31. Exactly.
So once you click on it, then click on apply down here.
Okay.
There should be a change now.
There is no change.
Okay, okay, double click
another thing
layer,
you have to
set
check.
to meter, yeah.
Another thing, yes, that's you go to property again, go back to property,
Okay.
then go to general. Under display, you will see display, choose meter.
General display.
Yeah,
Then
map,
choose meter.
Map display unit.
Do you see it?
Okay. Yes.
Yeah. I think that should solve your problem, sir. Is it changing?
Let me click OK. Yes, exactly.
Yeah.
So you're happy now, right?
Thank you very much.
You're welcome. So, but I'll still put it on the YouTube hopefully today. But I will. I may edit some parts that I say men and lady, or should I put everything?
Put everything.
I should put everything. It's all right.
Remember that remember before you put everything, remember that anything you post is on the whole world. Oh.
Exactly.
They will hear your voice now.
Everybody can see
it. That is why I asked now.
Anytime anybody clicks, forget about it. We are not saying anything bad, but what I'm saying that anybody anywhere in this world
that have access to it again.
In this part of the world, anybody that I click on this video, we see what. That's why sometimes I watch people that leave their video, their house is open as if it is a child's play. You are leaving your house and they are posting it on the internet. If you go to the virtual video, you see background. Select the background and block your background. And stop all this, you're taking tea, taking biscuit while we are doing this. It is going to be on the air. Don't think it's just in your house.